Consider the combustion of ethane. That is this stoichiometric equation right here. If the ethane is burning at a rate of 0.8 moles over liter times seconds, I put the parenthesis in here, otherwise it wasn't clear, that both L and S are in the denominator here. At what rates are CO2 and H2O being produced? Okay, well, I think once we know one rate, we can figure out the other ones from the stoichiometric equation. And they are looking, for example, CO2. For every 2 molecules of ethane, which we just said is C2H6, there are 4 molecules of CO2 produced. Okay? So there are 4 molecules of CO2 produced. So 4 here and 2 here. So in other words, if we want to know the molecules of CO2 produced, well, we know there's going to be 4 molecules of CO2 every 2 molecules of ethane times the number of molecules, which in this case is going to be the concentration, which is C2H6, right? So another way to derive this is by rewriting the stoichiometric equation, the stoichiometric equation, like this. We're going to say minus 1 over 2. So we're basically dividing by the coefficient. And then we're going to say C2H6, because look at what happens. Look at what happens. So this changes and is burning at a rate of 0.8. So this is the concentration at what rates are these being produced? Well, I don't think this is the right way to answer the question, because we don't. Yes, we have the stoichiometric equation. That's burning at a rate of 0.8. At what rates are CO2 and H2O produced? No, I think this is the right way. I just want to make sure. So let me go back here, and I want to look at plot the nope, not here. I want to look at this now, the rate of each species versus time. So this is the preferred way to write rates. So I made my explanation a little bit incorrect, because if I look at this, what I want to say is not exactly this. I want to say that the rate at which it is produced. So the rate is going to be C2H6 over dt. Now remember that this is decreasing, so this is going to be negative, so we put a negative in front. Now, this is where we write stuff this way from the stoichiometric equation. Negative 1/2 dt here is and minus 1/7 concentration of O2 over time going to 1/4 concentration of CO2 over time plus 1 over 6 concentration of H2O over time. And then this is not correct either. What we do is we set each equal to each other like this. And so now we can relate them, right? So this is going to go over here. This is going to go over here. And now notice, if I take the ethane and I take the CO2, I would be writing -1/2 times the rate at which C2H6 over dt is burning is equal to 1/4 times the rate of CO2 carbon dioxide dt. So I can multiply both sides by 4 and I get that CO2 over dt, which is the rate at which CO2 is produced, is equal to -4 over 2 C2H6 over dt. And we have this right here. So this simplifies to -2. And then they're telling us the rate at which ethane is burning, which is 0.8 molarities over second. And so this is going to be -1.6, meters per second. But this is burning, so this is negative as well, so this is positive. And that makes sense because CO2 is being produced at a rate of 1.6 molarities per second. So CO2 is being produced at a rate of 1.6 molarities per second. We can do the same for ethane and H2O. H2O is right here, so we would do, and if I skip some steps, we're going to have H2O over delta T, and this is the concentration of H2O. That's going to be equal to -3 because I bring the 6 to the other side and I divide by the -1/2 of the concentration of C2H6 over dt, which ultimately becomes -3 times -0.8 molarities per second, which is going to be 2.4 molarities per second. And let me back up because I don't like how I did this. This right here, 2.4. So I can write here 2.4, and they're both correct. So I hope this was useful for you. I'm sorry there was a little bit of confusion initially, and I'll see you next time.